Hi everyone, I'm Huita Solanki. I will be helping you in becoming familiar with the concepts of big data today. We will be starting with the introduction to big data, followed by how big data came into picture, how it became important in the past few years, and what will be its role in the coming future. We will be discussing real-world examples to understand it better. I'm going to start with this picture which is in front of us right now, which perfectly represents big data to a beginner. Till date, we have been using just the tip of this iceberg, storing it, processing it, and doing analysis on just this much amount of data. But with increasing technologies, rising competition, and exploding data, it made more sense to analyze a larger set of data than a smaller one. It became evident that more the data you have at hand, the more accurate your analysis would be. That's where came the concept of big data. So, in this module, we will be talking about what big data is, what are its characteristics. We'll be getting a detailed understanding about the need for a big data solution. We will be able to understand where big data is appropriate and where it is not, where it can provide a solution to companies' problems, where it cannot provide a solution to companies' problems. We will be able to list the IBM products that make up IBM's big data strategy. We will be able to describe the type of data which is appropriate for Infosphere BigInsights and Infosphere Streams. And at last, we will be able to list the open source programs that are a part of Infosphere BigInsights. So our next slide gives us the definition of big data. What is big data after all? How it is different from the normal data that we have been dealing with till now. Big data is a term used for a collection of data sets which is so large and complex that it becomes challenging to process it with traditional databases and computing systems. Challenges include capturing this data, storing it, searching within this data, transferring it across the network, analyzing it, and several more. To get a clear picture about big data, let's try to relate it with some real-world examples. So let's compare big data scale with some real-life scenarios. So 2.5 petabytes is the amount of memory that a human brain has. 13 petabytes is equivalent to the amount that could be downloaded from the internet in 2 minutes if every American got on a computer at the same time. So you can relate how big that data is. 4.75 exabytes is equal to total genome sequences of all people on the earth. When we talk about genome, we are actually relating to the DNA samples. 422 exabytes is equivalent to the total digital data created in the year 2008. 2.5 zettabyte is equal to world's current digital storage capacity, which is a lot. And as predictions say, 3.8 zettabytes will be total digital data expected to be created in the year 2017. Now we'll talk about the types of big data. So big data actually includes any type of data which is huge and which cannot be managed by traditional systems. So we do have structured data in the form of big data. We have semi-structured data and we have unstructured data. Structured data includes data from enterprise systems like CRM, ERP, which we actually store in traditional databases, RDBMS. Semi-structured data actually includes those files, like for example, we have XML files which are in a particular format, but it's not totally structured. We could give it some structure, but it's not a totally structured format. Like we have emails, we know we have a subject, we have to, write in a body, and then we just send it over. So we do have a format, but not every mail follows the same format. It could have a body, it could have a subject, but it's semi-structured. Now we come to the most important part, which actually 80% of big data in the world comprises of unstructured type of data. So what it includes, we all have been using unstructured data in some form or the other these days. It includes images, it includes videos, it includes audios, several web logs, and sensor data, and the list can go on. So now we'll be talking about the explosion in data and real world events that led to this explosion. So in recent years, we saw a huge explosion in the amount of data that the world generated. We can see that in the year 2005, there were 1.3 billion RFID tags. RFID is radio frequency identification tags. But today, this number has risen to 30 billion, which is a lot. The capital markets, this data volumes grew 1,750% in just 3 span of years, 2003 to 2006. Internet users became 2012 by the 4 billion by the year 2012, and we can see that 4.6 billion mobile phones were being used worldwide in that particular year. Now Twitter process daily it generates 7 terabytes of data. Facebook processes 10 terabytes of data each day. And World Data Center, only for climate, it uses 225 terabytes of web data. It generates 225 terabytes of web data and 9 petabytes of additional data for processing purposes. Now we come to examples of big data from several other dimensions. Like if we talk about commercial big data examples, so we can see that we have database logs are included in this category. Web events are included in this category. There are sensor networks, RFID tags, internet text and documents being transformed, internet search indexing, call detail records, medical records, and so on. Now we come to government things. Regular government business and commerce needs are included, and they also generate big data. Military and homeland security surveillance generates huge amount of big data from government's point of view. Next is science. Whether it's astronomy, whether it's biology, whether it's atmosphere, weather, or genomics, there's huge amount of data being generated every single day. Be it for research, be it for gaining enhancement in a particular project, be it anything, but science is generating a lot of data for good purposes, for human welfare maybe. Now we come to social part of this category. So we all know social networks generate the most data right now these days. Be it Twitter, be it Facebook, we all know that daily terabytes of data is being generated. So these were a few examples of big data. Now we are coming to this next slide, which is big data at organizations. So we'll be talking about how big data in various organizations look like and what does it help in really. So right now information is at the center of a new wave of opportunity. We will be expecting 44 times as much data and content as we have today over the coming decade. Now, why do we need big data actually at this point of time? We know competition is growing, organizations are growing. There are a number of organizations right now than they were few years ago. And organizations, to run their businesses, they need deeper insights into their data so that they can make better informed decisions, to make their processes better, to make their sales better, to make their business better. The stats say that 1 in 3 business leaders frequently make decisions based on information that they do not trust or they don't even have right now. 1 in 2 business leaders say they don't have access to the information they need to do their jobs. 83% of CIOs cited that business intelligence and analytics as part of their visionary plans to enhance competitiveness. 5.4 times top performers are 5.4 times more likely to use an analytic approach over intuition. So what we can conclude from this side is like big data, every organization needs to store this big data to make better analysis, to make better business decisions. So they do not just want to rely on intuition, or they do not want to rely on say reports being generated on a week's data or something. They want to have a data which could span over a year, 2 years, maybe 5 years, or maybe 10 years, to know what really is being signified or being implied from that data. So we need to have a large amount of data to make better analysis, to make more accurate analysis. Coming to the next slide, perception gaps surrounding social media. So here we will give the percentage of two types of categories: businesses ranking, how businesses rank these particular scenarios, and how consumers rank them. So business ranking, why they think consumers follow them via social sites, and why, and what are the actual reasons that consumers think they interact with companies via social sites. So it's very surprising to note that what consumers put on the top is what businesses put at the bottom, which is discount. Businesses think that their consumers come to their websites from social sites to learn about their new products, or maybe to gain the general information. But that is not the case. Consumers will visit their social websites mainly to get a discount. So this was revealed from big data analysis only. Coming to the next slide, we will give the big data characteristics as defined by IBM. So IBM actually gave the definition of big data based on 4 V's. We call it the 4 V's of big data, which is volume, variety, velocity, and veracity. Volume is the scale of data. How much volume of data is coming? It has categorized big data based on the volume and 3 more characteristics which will be coming on. So scale of data, it has to be huge. The data has to be in terabytes or petabytes or exabytes or more. The next comes variety. So big data, we have talked about it, it spans across different forms of data. It could include images, audio, weblogs, sensor, video, anything. It doesn't have to be in a particular structured format. Next comes the veracity. So veracity is uncertainty of data. Like for example, data is flowing in for a particular product or for a particular data company. It's not necessity that the next day data will be flowing for that particular product. It is just an example. So it's very uncertain. We could get zeros for that particular row, which we are getting a good number right now. And tomorrow we cannot be getting anything. Maybe day after tomorrow we'll be getting again. So data is very uncertain. It can come and it cannot come. Next is velocity of data, streaming data. Velocity data is really coming in at a very fast speed. So daily we are having a huge pile of data which is adding up, and we have to store it and we have to analyze it to make better future decisions. So these were the 4 V's of big data as defined by IBM. Now next, what challenges are there to be used for big data to find new insights? Like for example, they have given a few websites here, Facebook, be it Twitter or emails, anything. There are many challenges which are yet to be discovered, which are yet to be solved using big data techniques. So like detecting life-threatening conditions at hospitals in time to intervene and to better help the patients, to better help them at the right time, to diagnose it and to treat it. Next is predict weather patterns to plan optimal wind turbine usage. We'll be dealing with a more detailed study in the coming slides about that. Next is make risk decisions based on real-time transactional data. And next is identify criminals and threats from disparate video, audio, and data feeds. So these are few challenges that were being used or even that are being used to solve these problems. Is there really a need for big data? Of course, yes, but let's find out how. So Vestas is a company which optimizes capital investment based on 3 petabytes of information, and they have used IBM's product Infosphere BigInsights and Infosphere Warehouse to make informed decisions, and which have helped them a lot to actually know where they should be putting more turbines, placing more turbines. So they used these products to model the weather to optimize placement of their turbines, and which maximized power generation and longevity. It reduced the time required to identify placement of turbine from weeks to hours. Earlier, it used to take them week to analyze which place actually they should be fixing the next turbine, but now this time has been reduced to hours using this product. They incorporated 3 PB of structured and semi-structured information flows, and which helped them to get this data. And this data volume is expected to even grow to double the size to 6 petabytes. Now, case study at Vestas. Vestas Wind Systems has 43,000 wind turbines in 65 countries over 5 continents, which is a lot. So its pain point was that they did not have a proper technique, a optimal technique to find out how to place their next wind turbine, where to place it. So they wanted to find an optimal place to install it, and they must consider large number of location dependent factors for it to be located, like temperature, precipitation, wind velocity, and humidity. And what the pain point was, the existing legacy process didn't support all the data to be analyzed. So it could only analyze some amount of data, but not all the data. And they wanted this data to be analyzed in a span of few hours, not in weeks. So solution that was required was they wanted to something to allow leverage of all the available data, and which could drastically reduce the modeling time and support their future expansions with the modeling techniques. It also improved accuracy of decisions for wind turbine placement, contradictory to the traditional system. Now, implementation that was being made using Infosphere BigInsights, it created a wind and site competence center, and what engineers did the engineers modeled the data, and they forecasted optimal turbine locations. Initially, to use publicly available weather data, what they did was they used public weather data that was available from the National Weather Data Services or so, as well as they recorded their own data. Based on this much data, they analyzed what could be the best place to place the next turbine, and they were able to provide that solution in a very short period of time and with great accuracy. Data sources considered were global deforestation metrics, satellite images, etc. Infosphere BigInsights will be used as a core infrastructure to hold generated weather data. So that was a perfect example to understand how this IBM's product help a company to to make a better decision, to make a better informed decision, so that it could help cut down the time, and it could help in a better analysis and a better placement of the wind turbines, which was actually ultimately their business. Now, let's see how traditional approaches versus big data approaches are. Now, in what happened in traditional approach, we have seen like user sends a request. There is an application server, there is a database server which holds the data. So what this approach holds is client sends a request to the application server. Application server and the database server here are separate entities. So application server, it queries the database server to fetch the data. So this data can be on multiple servers. So then the analysis program can be run on any application servers, but first we have to query the database, and then the database will return the data, and then the processing will be done on the application server, and then it will be sending the result back to the client. So in all this process we can see there's an extra step. The data has to go through the network, which was eliminated in big data approach. Big data follows a simple strategy. It doesn't want the data to move. It wants the data to remain where it is. It brings the function to the data, the processing to the data. In big data approach, we have a master node and data nodes. For now, let's understand that master node is something which takes care of everything here. It's the heart of big data. Analysis program runs where data is present on the data node. It's the job of the master node to send the function to process on the data. Only analysis program has to go through the network, and analysis program need to be MapReduce. We just remember that we are talking about MapReduce, nothing more. We'll be discussing it later. And it's highly scalable, and big data structure should have a huge number of nodes to keep the data, and but the master node should have a strong high configuration, because it is the master and it needs to manage all the processing functions, sending the processing, taking care of everything that is residing on the data nodes. So this is the big data approach and traditional data approach. So data is sent to function. Data has to go to the network in the traditional approach, and only the function that will be doing the processing will be sent to the data nodes, and no data will be transferred across the network in big data approach. So let's see how business users and IT have been working together in traditional approaches and in big data approaches. So we'll see the difference. It's a beautiful example. In traditional approach, we had structured and repeatable analysis where business users gave us a question. They gave us a question like this is what we need. Determine, so what question to ask, right? Now IT structures structures the data to answer that question. So we get a requirement, we query the data, we run a select query or something based on the requirement, and then we provide that report to the client. This is what traditional approach was, and it works still. Now in big data approach, we have iterative and exploratory analysis. It's more of a exploratory thing. So IT provides a platform to the client to enable creative discovery. It's not a traditional discovery. Here the client doesn't even know what he wants to know from this data. So the question comes to the business users as to what they explore what questions they could ask from the ID to get from this much amount of data. So here a question comes later. So there could be many things. When you have this much amount of data, when you have everything at hand, you want to explore the data, you want to make more questions, you want to do more analysis on it to see from different angles how things can be made better, how you can make another better decision the next time. So this is how traditional system versus big data system works. Now coming to the enterprise information architecture. So big data will be a permanent part of your information architecture. It won't go. Since this is something ongoing, you'll be needing it forever. You want to do analysis on more and more data, and data is not going to come down. It is only going to increase. So big data has to be a permanent part of your information architecture. It cannot be a silo. It must be fully integrated in order to leverage its value. You cannot keep it separately. You have to integrate it with your existing systems to make full use of that and your data. So one of the characteristics of it should be that it must be easy to deploy and to be integrated with your existing enterprise systems. So let's talk about IBM Big Data Platform strategy. Integrate, they follow this strategy like to integrate and manage the full 4 V's of big data into the system, be it variety, be it velocity, be it veracity, be it volume. And then apply advanced analytics to information in its native form only. They do not want to change it further. They want to keep the data as such, and then they want to apply advanced analytics on that particular data. They want to visualize all data, all available data for ad hoc analysis. So they do not want to separate it out and then analyze it in chunks. They want to visualize all the available data that is at hand. Development environment for building new analytic applications. So they can use the enterprise existing development environment to build new analytic applications as well. Like for support, workload optimization and scheduling, they can use this one. And provide for security and governance. Security is definitely a very important part. So when this much amount of data is being considered, you want it to remain secure. And that's where big data can help you to. So integrate with enterprise software. So these are few steps of the platform strategy that IBM Big Data has. Continuing with that, we see this diagram. So we can see that analytic applications are reporting, the content analytics, exploration, visualization, industry app, functional app. There are several other things. So these are analytic applications which could be developed further based on your need. Big data platform, they talk about visualization and discovery, application development, and systems management. These are all the accelerators that we are talking about. Now here you can see 4 important things: Hadoop system, stream computing, data warehouse, and content management. So we'll see content management. This is particularly this index big data. So you can see that here we see data explorer, content analytics. So it actually indexes big data. It wants to use it, you're indexing on it, and to get more collaborative insights on that. Right. So now next, coming to data warehouse, it simplify your data warehouse, pure data analytics, pure data operational analytics. It helps to deliver deep insight with advanced in-database analytics and operational analytics. Now coming to stream computing, analyze streaming data. Like, so what happens is, like, this particular software, this particular product that IBM has, it will help to analyze and correlate information as it arrives from thousands of data stream sources, and it can analyze data in motion and extend the value of existing systems as well. So it is helpful in analyzing streaming data. So Infosphere Streams is the advanced analytic platform that is being used for that purpose. Hadoop system. What Hadoop uses is, like, Hadoop reduces cost. Hadoop basically, it follows a simple approach. You have to save data on systems which are less costly, in fact which are cheaper, I would say, not even less costly. And only the processing part, the master slave that we talked about, has to be the only server which has to be with a high-end configuration. What we need in data nodes is just a hard disk, hard drives, main memory, where we can actually store the real data. So Hadoop reduces cost because of the data nodes that it deploys, and it's a very cost-effective solution that helps to analyze petabytes of structured and unstructured information. So we have seen, and this is IBM's Big Data Platform strategy. Now moving on to enterprise class big data product at IBM. So this product that we'll be talking about, it is failure tolerant, it can scale economically, and it provides security and privacy. So when we say that it's failure tolerant, it means that it's highly available. It has an architecture which supports high availability, like it is present. It has to be up and running no matter what. So how that will be reaching out to later. And now what failure tolerance implies is, like, it has to be available all the time to support any hardware failure or application failure. In any case, this architecture has to be up and running. It has to be green all the time, no matter what. Scale economically, like if we need to store more data, what we can do is we can add more data nodes to the cluster. It won't cost us a lot. So we can add as many number of data nodes as we want on the cluster. These big companies, I guess Facebook uses like 3,000 nodes in a cluster, in one cluster. So these runs on scalable hardware with the ability to dynamically add additional nodes. It won't cost us anything, and it won't even disturb the cluster. Security and privacy. Security protection for granular data access control is being provided in this platform by IBM product. Next is different BigInsights editions for varied needs. So BigInsights editions, these are three kinds: Basic Edition, Enterprise Edition, and Pure Data for Hadoop. So Basic Edition is the free download edition, and Enterprise Edition is actually they sell it by the number of terabytes that are being managed in that particular edition. And Pure Data for Hadoop is appliance simplicity for enterprise. It's the advanced product. So characteristics that distinguish BigInsights includes its built-in support for analytics, its integration with other enterprise software, and its productive readiness. And for Infosphere BigInsights, there are two releases. One is Basic Edition and the other is Enterprise Edition. Now, Infosphere Streams, like I already discussed that this is an advanced analytic platform that helps to analyze and correlate information as it arrives from thousands of data stream sources. It has the ability to analyze data in motion, and it also helps to extend the value of existing systems with which it is integrated. So let's see what are its unique features. Complex analytics. So it can analyze structured data, it can analyze unstructured data, any data, video, audio, or other non-relational, non-structured data streams. And it's fast, clustered runtime for high performance, extremely low latency streaming applications. It is enterprise scalable, high availability, high via runtime start and recovery services. It's scalable. We can add as many number of nodes as we want. Here are a few of the upgrades that are being included in version 2.0. We can go through it. Platform for V3, analytics, usability, enterprise class, integration with all these things. So to summarize, an enterprise ready big data platform is what BigInsights is. Innovative, customer tested products, Infosphere BigInsights, Infosphere Big Streams. Platforms and products enabled for integration with the overall enterprise infrastructure. Even though BigInsights contains open source like other IBM software offering. So we see that it's open source, and it can be very easily integrated with the system. It helps to analyze any type of data, and it is a huge plus for any organization that is looking for deeper analysis. So after completing this module, what are we actually taking with us today? So first of all, the question is, what is big data? We all should be able to answer all these questions right now. What is big data? What are its types? What are the characteristics that define big data? What was actually the need for a big data solution in today's era? What are traditional solutions and big data solutions? How are they different from each other? How is big data solutions a better solution? What are the IBM products that make up IBM's big data strategy? We should be able to describe the type of data which is appropriate for Infosphere BigInsights and Infosphere Streams. And at last, we should be able to list the open source programs that are part of Infosphere BigInsights. So that covers our first module today. Thank you. If you have any questions, please let me know.